this example, we're going to start looking at dilations of radical functions. So we're going to have a multiplier out here, like this 2 that you see in example 2, and this 1/2 here that you see in the triad at the bottom. So this is going to affect the y values, so the outputs um, when we go to draw the graph. So first we'll apply the translation that you see on the inside of the function. So we'll ignore the 2 for a moment, and we look at this x plus 3 and the plus 5, and the plus 3 is going to be the left 3 shift that we've come to understand, and the plus 5 out here, we'll move the vertex up 5. So we'll start with that. We'll go ahead and do that translation. We'll go left 2, 3, and up 1, 2, 3, 4, 5, and that's where this radical will start its launch. All right. Now normally the square root function behaves like this. You go 1, 1, back to the red dot, 4, 2, but these dots are going to disappear, and we're going to change them. And then you would go 3, 4, 5, 6, 7, 8, 9, and up 3. Because the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. But what the 2 out here does is it changes those y values from right 1, up 1, right 4, up 2, right 9, up 3. It's going to change them to double. They'll go up 2, up 4, and up 6 instead, because it is doubling the outputs. Okay, so from this vertex, we'll go 1, up 2, back to the red dot, and then we'll go over 4, 1, 2, 3, 4, up 4, 3, 4. And then instead of 9, 3, we'll go right 9, 6, 7, 8, 9, and up 6, 2, 3, 4, 5, 6. We're off the screen just a little bit, but as you can see, this shape gets steeper by a factor of 2. So that is the transformation of 2 times the square root of x plus 3 plus 5. Now let's pick a point like this guy. That looks like the point 1, 9. Now, if I put 1 into this function, will it return a y value of 9? Just a quick check to make sure that we did it right. So if I put in 1, will it result in 9 as the y? Well, 1 plus 3 is 4. Square root of 4 is 2. 2 times 2 is 4. 4 plus 5 is 9. So that point checks out, and I'm pretty confident that the rest of these points would check out as well. Okay, so at this time, I'd like you to go ahead down and try it that you see here. I'm going to clear the screen. I want you to pause the video, try it on your own, and then play it and see how you did. All right, assuming you did pause the video like I told you to, you now see the answer on the screen, and the vertex moved right 1, down 3, and then the 1/2 cut these outputs in half. So as you can see, I made a quick little table here, and the normal movements or behavior here with the inputs and outputs are 1, 1, 4, 2, 9, 3, but due to the 1/2, all of these y's get cut in half. So as you can see, this square root function is a little bit flatter. It's not rising as quickly because of that 1/2. And forgot to mention, they did ask us about domain and range here. So the domain for the first one, it's only affected by the translation. So since it went left 3, the domain would be -3 to infinity. And since it moved up 5, the range would go from 5 to infinity. That's for the original example. For the try it, since it's right 1 down 3, the domain starts here at 1 for x and goes to the right. So 1 to infinity. And since the graph shifted down 3, the range, the y values reach a minimum of -3, and they go up to infinity.